When we look at the night sky, we see stars. With telescopes, we see galaxies. But beyond galaxies lies something far more astonishing. The universe is not random. It is structured on scales so enormous that they challenge human imagination. Galaxies are not scattered evenly across space. Instead, they gather into clusters, connect into filaments, and stretch across unimaginable distances in patterns that resemble a vast cosmic web. These are the largest structures in the universe, formations so immense that even light takes billions of years to cross them. To understand these colossal structures, we must begin with galaxies. A galaxy like the Milky Way contains hundreds of billions of stars. It spans roughly 100,000 light years. Already this is a scale that overwhelmed comprehension. But galaxies rarely exist alone. They are bound together by gravity into groups and clusters. Our Milky Way belongs to the local group, a small gathering of more than 50 galaxies held together by mutual gravity. The local group itself spans about 10 million light years. And this is only the beginning. Galaxy clusters are far larger. A single cluster can contain hundreds or even thousands of galaxies, along with vast amount of hot gas and invisible dark matter. These clusters are the largest gravitationally bound structures in the universe. One example is the Virgo cluster, containing more than 1,000 galaxies. But even clusters do not represent the ultimate scale. Clusters connect to other clusters through long, thread-like filaments of galaxies. These filaments stretch across hundreds of millions of light years. Between them lie enormous voids, regions nearly empty of galaxies. Together, these filaments and voids form what astronomers call the cosmic web. It is the largest known pattern in existence. If we could step outside the observable universe and look back, we would not see galaxies scattered randomly. We would see a network, a vast three-dimensional web of matter stretching across space. This web formed from tiny fluctuations in the early universe. After the Big Bang, matter was not perfectly uniform. Slight differences in density allowed gravity to pull matter together over billions of years. Regions with slightly more mass attracted more matter, growing into galaxies clusters and eventually superclusters. Over cosmic time, the universe evolved from a nearly smooth plasma into a structured network of immense scale. One of the largest known structures is the Sloan Great Wall, a filament of galaxies stretching over 1 billion light years. To put this into perspective, light itself, traveling at nearly 300,000 kilometers per second, would need 1 billion years to cross it. And even larger structures have been identified, such as the Hercules Corona Borealis Great Wall, which may span over 10 billion light years. These scales are so immense that they push against the limits of what the universe should allow according to certain cosmological models. Yet observations continue to reveal patterns of staggering size. The cosmic web is not merely a visual pattern. It is shaped by dark matter, which forms the invisible scaffolding upon which galaxies gather. Without dark matter, gravity alone would not have been strong enough to form these enormous structures so quickly after the Big Bang. In this way, the largest structures in the universe are both visible and invisible. The galaxies shine, but the underlying framework remains unseen. Beyond the scale of clusters and superclusters lies the observable universe itself, a sphere about 93 billion light years in diameter. Within this boundary, all the cosmic structures we see are contained. Yet even within this vast expanse, matter is not evenly distributed. The largest structures are balanced by the largest emptiness. Cosmic voids can span hundreds of millions of light years with very few galaxies inside them. These voids are not completely empty, but they contain far less matter than average. If you were located in the center of such a void, the universe would appear far darker and lonelier than it does from Earth. The existence of enormous structures in vast voids reveals something profound about the nature of gravity. Gravity amplifies small differences over time. A slightly denser region pulls in more matter, growing larger, while less dense regions become emptier. Over billions of years, this process produces a universe that resembles a foam or sponge on cosmic scales. The largest structures also tell us about the early universe. By studying their distribution, astronomers can test models of cosmic inflation and the nature of dark energy. The pattern of the cosmic web is like a fossil imprint of the universe's first moments. It preserves information about how matter and energy behaved shortly after the Big Bang. Even more astonishing is the idea that these vast structures are still evolving. Galaxies continue to merge. Clusters collide. Filaments shift slowly over billions of years. On human timescales, the universe appears static. But on cosmic timescales, it is dynamic and alive with motion. The largest structures are not permanent monuments. They are temporary arrangements shaped by gravity and expansion. Dark energy, the mysterious force driving the accelerated expansion of the universe, will eventually stretch these structures apart. In the far future, galaxies outside our local group may recede beyond the cosmic horizon, becoming invisible forever. The cosmic web may thin and fade as expansion accelerates. The largest structures we observe today are snapshots of a particular era in cosmic history. They represent a balance between gravity pulling matter together and expansion pushing it apart. The sheer size of these formations challenges the limits of imagination. When we consider that Earth is a small planet orbiting an ordinary star in a typical galaxy, which itself is only one member of a cluster embedded in a filament stretching hundreds of millions of light years, we begin to grasp how small our place truly is. And yet, from this small vantage point, we have mapped the largest structures known to exist. Human curiosity has extended across billions of light years, revealing a universe shaped like a vast network of light and shadow. The largest structures in the universe are not just astronomical curiosities. They are evidence that the cosmos is order, that gravity sculpts matter into patterns across unimaginable scales. They remind us that beyond the stars and galaxies we see lies an even greater architecture, a cosmic web stretching across space and time. And within that web, our galaxy is only a tiny strand in a structure so vast that it may take the lifetime of the universe itself to fully comprehend.